Okay, in the previous podcast, we looked at molarity, and it's a way of showing how concentrated a solution is. So the higher the molarity, the more concentrated it is. The lower the molarity, the more dilute it is. Okay, there's another conversion we can do, and that's going from liters of A to liters of B. It's a lot like grams of A to grams of B. We did in chapter 3. Here are grams of A to grams of B when they're across here. And we went from grams of A to moles of A using the molecular weight. Then went from moles of A to moles of B using the mole-to-mole ratio. Then we went from moles of B to grams of B, again using the molecular weight. Okay? But this time what we're going to do is we're going to start with liters and go to moles. You see here we're going to use the molarity of it, the moles per liter, right? Because if you look at molarity is moles per liter, so it has moles in it, so you can cancel them out. And then we're going to go to the mole-to-mole ratio, and then go back down to liters of B using the molarity again. Okay, so let's look at an example. Actually, let me write down our pathway. Okay, we're going to go from basically liters to moles. So we put liters of A, moles of A. Remember, we're always going to B, moles of B, to liters of B. Now, if you can imagine, when you do this, it's going to have a liters in the problem. It'll give you liters or milliliters, some unit of volume, and then it's going to ask you what the final liter is. Okay, so our pathway here, we're going to have some amount of liters of A, liters A, okay, and we're going to convert this into moles of A here. So we're going to have liters of A at the bottom, moles of A at the top. And this is just through the molarity. You put M at the top. That's just the molarity of that solution. And then we're going to go to moles of B. Remember, anytime you go from a mole to a mole, that's the mole ratio. So A moles of B. You see, this is very similar to the gram to gram, with the mole-to-mole ratio. And here, instead of grams per mole, we'll have liters per mole, okay, just because we start with a different unit. And then our final one, so this is the ratio. And then over here, we're going to use the molarity again, but since we have moles of B right here, we're going to put moles of B here, and then liters of B at the top. Okay, so this is our pathway for liters to liters. Again, very, very similar to what we were doing with gram to gram. So let's look at our whole problem here. Okay, what volume of 0.15 potassium chloride solution is required to completely react with 0.15 liters of a 0.175 molarity solution according to this equation? Okay, so do you see that it asks for liters? What is the liters? Okay, so this is our B, because whatever volume they're asking for, that's B. Okay, so we want, I'm going to put it down here, or actually let me put it up here in the corner. We want liters of B. Question mark. We don't know what that is, because that's what it asks for at the very beginning of the problem. What volume? To completely react with 0.15 liters, okay, of lead nitrate. Okay, so liters of A, because that's what we're starting with. I think it was 0.15 liters. Let's see. .15 liter, yeah. And the molarity is 0.175. Okay? And the molarity of A, I'm going to put MA is 0.175. 0.175. Let's make sure we have all of that down. Yeah, 0.175, 0.15, 0.15. Okay. Oh, and the molarity of B, do you see, is 0.15. So, molarity B equals 0.15. And let's look at the mole-to-mole ratio. So we're looking at KCl to lead nitrate. So KCl to lead nitrate. So these two right here, because that's what it says. This to this. So there's 2 KCl per 1 lead. So just remember that. We'll come back to that. Okay, so let's make sure we know where everything came from. What volume? So right away it says what volume. So anytime we're solving for volume, that's going to be our liters of B. Of a 0.15 molar KCl solution, so that's our molarity of B. So volume of B we don't know, here's our molarity of B, is required to completely react with 0.15 liters of A, because that's what we started with, we have that liter, and 0.175 molarity of A. So there's a lot of kind of blah 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 in between, you know, solutions completely react with this and then do that. So just kind of look at what you have. You have a liter, molarity, liter, molarity. And see, that's what we need for where you have a liter, and molarities in between. Okay, so this is a liter to liter. Also notice it asks you to solve for a liter, and it gives you a liter. Okay, so those are just different hints to show you that this is a liter to liter problem. Okay, let's start it out, and let's put our numbers in. Let me put in, let's use blue, I guess. So what is our liters of A? Liters of A, we put over here is 0.15. 0.15. Okay, and that's going to cancel out there with liters of A. What is our molarity? What is our moles per liter? And that is of A. So molarity of A is 0.175. And that's going to be 0.175 per 1 liter. Because when we write this again, molarity equals to moles per 1 liter, if you want. So it's going to be, when you give a molarity, like, molarity is 0.175, another way of writing that is 0.175 moles equals 1 liter. So in 1 liter, there's that many moles. So the number always goes with moles. So kind of like when we had a molecular weight, okay, and that was in grams, so let's say 12 grams equals to 1 mole. It's the same kind of thing, okay, except now the number goes with moles. Alright, now the next one is our mole-to-mole ratio. So A, oh, I should have put this down. A is our lead nitrate, and the reason that one's A is because that's what we have the liters. Remember, our B is always what we're solving for, so that'd be KCl. So let me put on here A equals to PbNO3 2. Okay, and our B is KCl. Alright, so we want to know what is the ratio of, in this case, B to A. Okay, so let's write down how many B. The ratio is going to come from the equation here. So KCl, we have 2 of those for every 1 of A. Okay, so for every 1 of A, we have 2 B. Again, B is KCl, so the number in front of it is 2, and the number in front of A is 1. So let's look at that again, make sure you see it. So KCl is 2 right there, and PB2NO3 is 1. Okay, so that's the 2 to 1. And that goes with KCl because I said that was B. Now the last part here is molarity of B, okay? And molarity of B is 0.15. So remember, the number goes with the moles, so that's 0.15 moles per 1 liter. Okay, now let's multiply this all out. We have 0.15 multiplied by 0.175 times 2, and that whole number divided by 0.15. So I'm getting 0.35 liters. And this is the final answer here. So let's see what we solve for. It says, what volume of this solution is required to completely react with this solution according to the following equation? So basically, if I want to completely react with this, so there's none of it left over, how much of KCl do I need to add in there? Okay? Because I want the reaction to go to completion. So I want these to react, or there's nothing left of them. They fully go to product. And so what do I need? How much of this do I need to add if I add 0.15 liters of this? And the answer is 0.35 liters. Okay? So if I add 0.35 liters of potassium chloride in there, it will be able to completely react with the lead nitrate 0.15. And let's see if there's another. I don't have another example. But it's the same thing. So again, let's just write out really quick the setup for this. And you just have to plug in your numbers when you get this. So it's very similar to the grams one, the gram to gram. Except we're going from liter A to liter B. So we're going to go liter A. So I need liter A to cancel out, so I put them at the bottom. And that will get us to moles of A. Okay? And this is just from the molarity. Now here's where I convert from moles of A. I'm going to put this at the bottom so it cancel out. And here, moles of B. And then I want moles of B to cancel out. And then I'm going to put liters of B at the top. And that's from molarity. And that is from your ratio, mole to mole ratio. And this is from the chemical equation. Chem equation. Okay, that's just the number in front of it, the coefficients. And these are from the molarities here. And remember, the number, the molarity, will go on the mole portion there. So let me put kind of an X. This is always like a X per 1, X per 1. Okay, and everything else, you just kind of fill out the numbers. Now let's look at a dilution problem. Okay, now let me show you how to recognize a dilution problem. A dilution problem will say dilute or dilution in the problem. And the formula here is M1V1 equals M2V2. Okay, your initial molarity and volume and what you want the new molarity and volume to be. So, for example, to what volume should you dilute 0.2 liters of a 15 molar sodium hydroxide solution to obtain 3 molar sodium hydroxide solution? Okay, so basically in a beaker, I have this 15 molar solution. Okay, and I have 0.2 liters of it. Now I want to know how much water basically to add to make it only 3 molar. So right now it's 15 molar, so it's very concentrated. I want to make it less concentrated. I want it now to be 3 molar instead of 15. So how much water do I need to add to dilute it? Remember, diluting it means not as concentrated. So you're adding more water or more solvent to it. Okay, so again, you recognize these problems because it'll say dilution or dilute or some form of dilute in there. Okay, so our formula is M1 V1 equals to M2 V2. Okay, now let's write our numbers down. Let's write down M1 V1 M2 V2. Let's write down what they are from the problem. Okay, so M1 and V1 will be your initial numbers here. So, to what volume should you dilute a 0.2 liter 15 molar solution? Okay, so that's our initial. So 0.2 liter and 15 molar. Okay, so initially I have molar, 15 molar, and 0.2 liters. Okay, and I want to get it to 3 molar. Okay, now how much more do I need to add? Okay, so I want to get it to 3 molar. And so V2 is basically how much are you adding? I don't know. So let's put this in. So M1 is 15. Volume 1 is 0.2. Okay. M2 is 3. And V2 we don't know, so I'm just going to put V2. Okay, so let's figure this out. So first let's do 15 times 0.2. 15 multiplied by 0.2 is 3. Okay, and then we have 3 V2. So now it's multiplied here, so we're going to divide it when we bring it over. So 3 over 3 equals volume 2. Oops, 2. So that'd be 1 liter is volume 2. And if I put my units in there, so I have M, L, M. We don't have a unit there yet. You see my molarities will cancel out, leaving us with the liters there. Okay, so I need to add 1 liter of solvent to make my new solution. So again, anytime you see dilution, you're just going to use this formula right here. So have your initial concentrations and volume here, and then this is what you're trying to solve for over here. Okay, and that's all I want to go over right now. I would say the hardest part, I think, with any sort of mathematical based science, physics, chemistry, biology, is trying to figure out what type of problem you're dealing with. Is it a dilution? Is it a liter to liter? Is it a gram to gram? What is it? Once you figure that out, then it's not too hard, because once you know it's a liter to liter, you're like, oh, okay, I know how to set it up. I know to go to liters to moles to moles to liters. Or if it's a dilution, I know to use the M1V1 equals M2V2. Okay? So I would say go through a problem and just see if you could figure out what type of problem it is. Again, if it's a dilution problem, the M1V1 equals M2V2, it's going to say dilution in there. If it's a liter to liter, it's going to give you liters. It'll have liters molarity, and you need to solve for a liter given a molarity. So you're going to have 2 molarities, 1 liter, and you're going to solve for a liter. So anytime there's a lot of molarities and liters in a problem, and it does not say dilution in there, then it's a liter to liter. You see, this one has a molarity and a liter and a molarity, okay, and it wants you to find a liter. So it looks like a liter to liter. All right. And technically it kind of is. But since there's a shortcut to this one, since it says dilution in there, then we could just use the M1V1 rule, okay? But if it does not say dilution or dilute or any sort of form of that word in there, then it's a liter to liter problem. Okay, so start trying some examples and good luck.